Okay, and we are live. Hi, welcome, and thanks for joining us today. You are watching GraphQL Wrocław edition number 8, and we are live from our beautiful HQ here in Wrocław. My name is Jakub, and I'll be your host for tonight. Just to say a few words about me, I'm a lead developer at Sailor, and in case you haven't heard of Sailor before, Sailor is a headless GraphQL-first open source e-commerce platform. And if you'd like to hear more about it, make sure to visit sailor.io. The link should pop up in the banner below. Also, we are hiring, so if working on an open source code base and shaping the future of e-commerce sounds like fun to you, then definitely hit us up. All right, so we've got some fantastic talks lined up in today's event. First, you will see why GraphQL fits perfectly into microservices architecture, and also see some real-life production examples along with its challenges. Next, we will hear about why GraphQL plays a big role in building the next generation of web. And finally, we'll explore a secret API design pattern. So be sure to grab your favorite drink and sit comfortably because we've got awesome content prepared for you today. And before we go on, as usual, we will have a QA slot at the end of each talk. So if you have any questions, now this is important, be sure to write them down during the presentation, and our guests will do our best to answer those questions after their talk. Okay, so without further ado, let's jump right into the first presentation by Roy Dirks. Hi, Roy. The stage is all yours.
Hey, thank you. So let me share a screen for you. So hi, everyone. So my talk will be about why GraphQL is perfect for microservices. And in this talk, I'll be showing you several things. But before we're getting started with why you should use microservices, or maybe why you shouldn't, because this talk won't be about why you should use microservices, but in case you have them, it will be a nice talk to see how you can use them with GraphQL. And to emphasize why I'm not saying you should or shouldn't use microservices, is I brought a meme for you today. So this is a nice one someone shared on Twitter, I believe. So when your boss tells you we're converting to microservices, and then in the end it will be all these sort of shipwrecks trying to bring all the containers on the shore instead of one giant monolith that brings the containers all efficiently. You now have, I don't know, let's say 5 or 6 somehow shitty boats that are trying to bring your containers to shore. So microservices aren't always efficient. So especially if you're a smaller company or if you're not serving that many customers, make sure to stay away from microservices. But if you have a fully distributed system and serving tons of customers, then microservices might be a thing for you. And if you have them, I'll be showing you how you can actually use them together with GraphQL. So before that, a little bit about myself. So as was mentioned, my name is Roy. You can find me on Twitter with the handle @GetHackTeam. I'm a entrepreneur, software engineer. I speak at conferences and I write books about React or GraphQL. There is a new one coming up about React soon, as React 18 will be launched, hopefully soon, somewhere in the next weeks or maybe next month. Day to day, I work with a company called Stepzen and also my own company called Hack Team, in which I give trainings and workshops about GraphQL, React, TypeScript, all these kind of technologies. But to know more about me, just follow me on Twitter. And so what do you already know about GraphQL? Well, probably a lot, because we're at the GraphQL Meetup, of course. So in this talk, I'll be skipping the parts about why you should use GraphQL or why GraphQL is really awesome. But I will be showing you why GraphQL is perfect for microservices, because GraphQL is truly perfect for microservices. And a lot of microservices I saw, they were using Rest or another protocol, or maybe not even really using a protocol to communicate between the services. And often these microservices would have an API gateway or a data layer or a service mesh or whatever you like to call them, that sits on top of all these microservices and tries to route your data around. But you can do this more efficiently with GraphQL. And why is that? Because GraphQL is all about graphs. And as you probably have been using GraphQL before, you understand the graphs that make GraphQL cool, especially with recursive types. And whenever your query is trying to load multiple types that have relationship with each other, you really see that GraphQL is bringing a huge bonus point. And if you build your GraphQL server yourself, then probably you have to make sure that all your resolvers are either query resolvers or type resolvers or field resolvers. That's something we'll be skipping for today, because today we'll be talking about microservices and especially why they are great for GraphQL. And the biggest point for this is, as GraphQL is thinking in graphs, microservices are really domain-based. And I've seen a lot of microservices that were domain-based or were combining multiple domains into one. It's something I generally advise people not to do. Also brings me back to the point in the beginning. Like most companies probably don't even need microservices because they're not big enough in terms of users to actually need them, or they have a small development team. So why use microservices? And I think microservices are often added to a stack because developers like to build microservices, and also because people think it's needed for the servers or to keep things actually separated from each other. So if you decide to do microservices, make sure they are domain-based. So you don't want microservices that overlap with each other or are dependent on one of another. Each microservices should be, I always say microservice is like a pure function. It should be aware of what comes in and what comes out, but it shouldn't be aware of what any of the other microservices are doing, because microservices should be a service on its own that's domain-based, has one single purpose, maybe multiple purposes, but always within the same domain. So if you would have a client that talks directly with a microservice, and this is usually not the case, because usually any microservice would have some sort of API layer, gateway, data layer, whatever you like to call them, on top of it, that distributes routes from all these services to one client. But suppose you have a client that's talking with microservices, always make sure they have their own domain. And it's important to emphasize this, and I can't emphasize it enough, but each service should have its own domain. So make sure that's really the case for your application. So what does it look like? Something like this. So suppose you have a client, it has to get something from your authorization service, which is a microservice. So what it will do, it will probably call the API of that authorization service either directly or through some sort of mesh or gateway, and then that service will return the token. So that's the only thing that service should do. Probably that service should also validate the token, but that's something I'm not really showing in this setup. But probably your authentication service is only doing things related to authentication. So it's requesting tokens, then returning a token, probably validating it, or maybe creating new ones based on your creating new ones based on your refresh token. So those are the only things your out service should do. And then your client can take this token, it can send it to the user service, and the user service can validate it through the out service, or the client can validate it on its own. But what should be really clear from this is each service should have their own domain. And those domains shouldn't overlap. They should be tightly correlated. and not being overlapping with each other, especially not in this scenario. So these are all domain-based. And then the nice thing, if you combine them with GraphQL, is that each microservice can have its own graph, or schema in this case. So whenever you'll be using GraphQL for your microservices, it is advised to create a schema for every service. So every service should have their own schema, and then later on, there are multiple ways to bring them together in one schema. But first, let's have a look at those graphs. So suppose we have this setup again. We have authentication service, a user service, a post service. And the authorization service is just doing stuff with authorization, and the user service and post service are also domain-based. And if you create graphs for this, you would have an authorization service, which should have a type maybe called auth or token or user. Not actually user, because user will be a user service. So the user service will have a user type, maybe an address type. I don't know, maybe something else. What else have we got besides addresses and user IDs and whatever that should be in that service. And then we would have a post service, which probably have a post type and then a query to get all the posts, maybe to get all the posts filtered by maybe something like an author or a keyword. And the same can be said for the users. It can also have some sort of filtering, but all these services should have their own graph. So when creating microservices for these REST services, in example, or whenever you're creating these microservices in GraphQL directly, always create a schema that is not reliant on any of the other schemas. So as the auth service is domain-based, it shouldn't be aware of any user types. And the same can be said for the user service. As it's domain-based, it shouldn't be aware of the post type, in example, of post it could be linked to as an author or maybe as a contributor or editor or wherever you like to connect them. So these domains truly are graphs, or as we're using GraphQL, there will be schemas. And whenever you're creating these microservices with GraphQL or REST, it doesn't really matter. Make sure they have one schema. And in REST, you can, of course, also create your OpenAPI schema, and then you connect them through GraphQL later on, as I'll show in a demo. But just make sure the schemas are really domain-based. And then, of course, you can use GraphQL to bring them all together in one schema. So I already said microservices are typically not interacting with a client directly. Often it's being done through a gateway, data layer, or mesh, or whatever you like to call them. And the same can be said for GraphQL. And suppose we have some sort of data layer, then this data layer would be the perfect communication for this data layer would be GraphQL, of course. Because with GraphQL, you can combine schemas, and you can do this in multiple ways, as I will be discussing later. But what's most important is that you can build this data layer in GraphQL without having microservices in GraphQL. You can, of course, bring together GraphQL schemas from your microservices in the data layer, but it's not necessarily something that needs to be done this way. So your auth service can be in REST, your user service can also be in REST, your post service can also be in REST or GraphQL. It doesn't really matter, because this data layer or gateway, this will really be the place where you bring together all these microservices. And I especially like a setup like this because not every service is utilized best using GraphQL. So an example, the auth service, it could be easier to just build it in REST because maybe already some team built it in REST and it's a legacy project. Or maybe one of your teams doesn't like GraphQL or has no experience with it. Or maybe you're investing in some third-party API that you're paying some SaaS company in order to distribute you some APIs. Then it could be really nice if you can bring those together in that data layer without having to rely on an API that isn't built in GraphQL. So merging these things in GraphQL can be done in multiple ways. One of the first ways to do it was schema stitching. And I believe we have someone from the guild in this meetup as well. So make sure to check out their projects related to schema stitching. They have a lot of cool tools in the open source library GraphQL tools. And with schema stitching, it's a good approach. But it is a lot of, it takes a bit more coding than the approach we'll be showing later on. But schema stitching is especially nice if you want to have a lot of control about what's going on in all the schemas you try to bring together in a data layer. And schema stitching was first designed by Apollo, and then later on, the guild took over the project, in which Apollo introduced Federation, which is another way to bring together GraphQL schemas. It's Apollo has its own implementation. Stepsen, which I'll be showing you a demo from later on, also has a federation implementation. And there are more companies that introduce federation for GraphQL schemas. And federation is a way to bring together schemas on the schema level, not so much on the resolver level. And then the third option you could have is remote schemas. And remote schemas is especially nice if you work with third parties or you have a very large organization. So I won't be mentioning these today. Let's focus on federation because that's the most obvious example I can show for this microservices setup. So let's see an example. And for this, I use Stepsen. And with Stepsen, you can create a GraphQL API based on any data source. So the data source can be a database, it can be a REST API, or it can be a GraphQL API. And as these can also be GraphQL APIs, you can also use Stepsen to create this data layer or API gateway for your GraphQL microservices. And even if these microservices are using REST, you can still use this tool in order to generate a GraphQL API for you. And one of the bonus points you get here as well is that it automatically deploys a server for you. So you no longer have to worry about deploying services or making sure that your gateway is available, because Stepsen will do this all for you. So especially if you're into serverless and you're working on the front end and you don't want to mess with servers, then it can be really nice to check it out. Also, if you're on the back end, it can make your work a lot easier, because I often see backend developers that don't like to build GraphQL APIs. And with a tool like this, you can have one built for you instead of having to build it yourself. So you can still use all the REST APIs or any other APIs that you created and build GraphQL on top of it. So what does it look like? Go to a code example. Clean this terminal for you. Let me just clean all this for you too. So what I've done, I've created a small example project. Maybe make this a tiny bit bigger. People with bad eyes. And so what I've done here, I've created the most simple microservices setup you can have. So I created just a JavaScript project. It's a package.json. I'm not doing that much. I'm just creating a start script that will start 3 different microservices. So I've built microservices with probably with JavaScript, but I should have built them in TypeScript. But I've built some JavaScript microservices, and these microservices will all have their own endpoints. So we have the authorization microservice, the post, and the users one. So these are just the ones that you saw in the slides before. So let's have a look at the authorization endpoint. And in order to build these, I've used a tool called JSON Server. And with JSON Server, you can create a REST API based off just a JSON file. So this auth file, it's not really relevant. It's not using a JSON thing. So what we're doing here, we have this auth file, and what it's not using the JSON, because the only thing it does, it's actually creating a token for me. So this microservice will create a token for me that I can use in order to send requests to any of the other microservices we have. Let's try and start this thing up. Just here on start. Now it will start all my individual services, and it will also make them available on an external link, because Stepsen only works with endpoints that are available to the internet, so you can't use it for your local development because it already deploys a server view to the cloud. So it should know where it can find these endpoints. And so our user service will be available on this endpoint, or post service there, or out service there. So these endpoints are the ones you can also use to connect with your microservices. So if you want to request a token, you should send a request to the out service that runs on this endpoint. Same goes for post and services. So what I've done here, I actually built a GraphQL API for any of these services. So we have an authorization service. There's a type called auth. It has an ID and an access token. And it also has one query, which will return the access token, of course. And this query will send a REST. We'll send a request to a REST endpoint, which is this one. So basically, it will be using the client credentials method of OAuth in order to get a token. And these client credentials are my user environment, so I have them stored somewhere, probably in this file. Yeah. So this file is where I put all the configuration for steps in. So these are all the different services. Just fill them in. So we have. I'm using local tunnel for the service, by the way, which is quite nice because you can use it for free. So what it does, it actually creates a port for my local environment. You can see I have all these things running on different ports. And then it will just create an endpoint that I can access in the browser or through the internet, through any other tool. Just replace this host names. So we will have a user service, which is this one. We'll have a post service, which is this one. Here. And then we will have a authentication service, which is this one. Save that, and then I should create a separate terminal. Version for you and clear this up. And then I can just run and start. We'll create the GraphQL API for this for these microservices. See, I need to upgrade, so let me do that in the background. So what are we doing here? And I will get back to the example shortly. So what you need to do in order to use or to build this data layer for your microservices, the first thing you do is create a schema for every microservice, unless they already have GraphQL. So if you're not using GraphQL for your microservices, make sure to create a schema for every microservice. And this can just be a GraphQL file, because the way StepSen parses them later, it only looks at GraphQL schema design language. So every microservice will get their own graph or their own schema. And then we can merge them together with just GraphQL schema design language. So I'll be showing you that in a bit. So let me quickly peek. Yeah, so this is updated. Start the service. So now it will automatically deploy a data layer that I've built for these three things. And then it will automatically deploy this thing here. So what it does here, it already has my my queries that I have. So that is query to get a token. So what I could do is do something like query token, access token. This will get me an access token. And then, of course, I have schemas for all the other services as well. So I have my post services, which has a query to get all the posts in there. And this is all based on a REST endpoint that was created by my microservice. And I will share the link to the example later on. So what we could do here then, we can take this token, and then of course we can also request some posts. We should provide an access token, which is this one. Open the terminal, copy it, this, and put in a title. And then as this is OAuth, I probably need to append mirror to it as well. A little bit. Maybe I shouldn't add mirror. This will get me all the posts for my microservices. But the neat thing is you actually want to combine this, because you don't want to retrieve a token every time from your query before you actually get stuff from your microservices. So one of the cool things you can do with StepSen is you can actually use custom directives in order to combine multiple GraphQL schemas. If I would go here, no, actually we look at the post. If I go here, So we have something called a custom directive called a sequence. And in a sequence, you can do multiple queries in a certain combination. So you can first do the query to get a token, which I showed you on the GraphQL editor. So it will first get the token, and then it will use the output of this query as the input for the second one. So the second one is a query to get all the post information. So what I can also do then instead is something like this. I can posts, do anything else. I just need to say I will get the title. This. And now what it does under the hood, which you don't see as a consumer, it will first get the token, and then it will use the output of the token request in order to distribute the token to the post query. So this way you can hide a lot of business logic from your microservices and also create a data layer that combines all these different schemas into one schema. And this data layer is truly where the magic happens. So if you already have APIs or microservices in this case that are using GraphQL, you can already combine them in the data layer. If you don't have GraphQL schemas for your microservices because they're using Rest, they're using something else, you can still create those GraphQL schemas for them and merge them together later on. And then the neat part here is also that you can deploy them serverless without having to write any pipelines. So if we will go back to the SDL, we'll have here. So every time you will make a change, so let's suppose we, I don't know, maybe add a line here and save it. You can see a file has been changed. It will start deploying to StepSen, and then a new endpoint will be available. So in our IDE, this would still work because the endpoint is still the same. So this is an endpoint for my account. But from your local environment, you can make changes, and then these will deploy to the cloud automatically. So you no longer have to worry about building any pipelines or making sure things are correct. And the cool thing here is, of course, GraphQL has a type system. The type system here is added in compile time. So if I would be adding stuff here that doesn't exist, so maybe I'll add something like a new field, and let's say this is an integer. Probably I will get an error here somehow because it will need to find this new field. And if this new field hasn't been specified somewhere, it will be catched on compile time. So one of the nice parts here is that you don't have to worry about the GraphQL type system as soon as you deploy these things, but instead it will be done during this compile times. And also this is not compiling probably, or it did compile and it can find this one. So these are interesting things to play with. So the neat point here is that the type system is also integrated while you're deploying stuff. So you can be fairly certain that you won't be giving any runtime errors to your users. This is the IDE. Yeah, so deploying them serverless is one of the added features you will get. And then I think we almost killed the half hour. So what you can see here is the GitHub repository, or actually the organization in which you can find these examples. If you would look here for something called Microservices, you will find the actual project I just showed you. And then in order to run it, I think it's in the README. Just double check. Yeah, so make sure you create a StepSen account, you run yarn start. You need to run yarn install actually before. So let me just type it like this. Make sure to also install the dependencies because it's using local tunnel in order to create those deployed endpoints for the microservices. And also it's using JSON server, which is a library to create REST API endpoints based on a DB.json file, an example, which makes it really easy to mock services if you don't have them live yet. And then make sure to run it. It will create the deployed endpoints for you. And then it will just ask you to put it in the configuration.yaml. So that way StepSen can reach them over the internet. As I said, it's being deployed serverless. So it doesn't work with any local running endpoints. Instead, make sure to make them available on a local tunnel. And also it has some more credentials which you don't really have to worry about. It's just an implementation of OAuth. And then if you would to, change your own microservice into this, and make sure to have a look at all these different GraphQL files, and also this data layer file, which brings everything together. A bit short on time to explain all the details in here, but the documentation is pretty concise. And maybe we have some time in the Q&A later on. So with that, I'd like to thank you. Make sure to follow me on Twitter if you have any extra questions you maybe not have time to ask today, or if you have any personal questions you'd like to ask, then Twitter would be a good place to start. So thanks everyone, and then hopefully you have some nice questions for me in the QA.
Thanks, Roy. That was some good stuff in that presentation. I can speak from experience. It's always a pain to deal with like multiple API endpoints on the front end. So having a single place to get all the data from is much better. Plus it makes the caching easier. Okay, so let's see if we have any questions. So the first question would be, how do you deal with temporary service outages? For example, if you have query that requires the token from our service and the service is temporarily unavailable.
Yes, so that is you will handle it in the same way as you would do with any gateway. So if you can't get a token, then your service is unavailable. So you either need to serve cached results, which can be tricky because maybe someone is sending an invalid token and is trying to hack your system. So in general, I would say not return any data. And there are some custom directives in order to tell GraphQL what it should do. So if you have the sequence custom directive that is showed, it will take a number of queries and use the inputs for each other. If something is failing there, you can just revert to something else and then probably return an error object to someone, because I believe we're using mostly error objects in order to return error. So it should be the same as with any gateway, unless you want to take the risk of serving cached results.
Cool. Thanks. Let's see if we have another question. Okay, so another question from Michał. Is there a caching mechanism under the hood?
Yes, definitely. So there are multiple caching mechanisms. So it will automatically cache all the results unless you have any secrets in there. And also it will cache results whenever you're doing. So in GraphQL we have data loaders, and if you're using data loaders in your server you built yourself, it will help you cache results when you have to call reservables multiple times. So StepSend is doing the same thing. So whenever you're calling a database table multiple times or a REST API multiple times within the same query, it will also implement caching there to help you not falling into any N+1 errors. Or not really errors, but N+1 inefficiencies, making sure you don't do any extra calls to either endpoints or databases.
All right. Do we have any more questions? Okay, so it looks like that would be it. Thank you, Roy, very much. Very cool presentation.
Yes, thanks, and looking forward to the next talk. So I believe Arthur is also doing a talk about microservices. So if you like this talk, stick around.
Yeah, definitely. So you've heard in Roy's presentation why GraphQL fits into microservices architecture, and you've seen some cool examples of that. Now you might be wondering how the process looks like in real life, large-scale scenarios, and what challenges it comes with. So our next guest, Arthur Smelt, has got you covered. Arthur, take it away.
Okay, thanks for the introduction, Kuba. So, as you may heard from the previous presentation, the GraphQL is perfect or nearly perfect for the microservices. In today's talk, I will quickly present you how we have approached the microservices problem in a more larger scale project. But first of all, let me introduce myself. My name is Arthur, and I'm a lead developer at Mirumee. On my daily basis, I work on one of the commercial projects, which is quite microservice heavy. During the implementation of that project, we have shifted our REST endpoints to be covered with the GraphQL data layer. So about this talk, all the examples are taken from a real-life scenario. The project used 15 plus microservices, which were using classic REST API. Most of the backend's code base is written using Python, and we have both synchronous and asynchronous services in stack. And as Ray mentioned, microservices are not always a good solution. However, in this project, we already had a few of those, and we have dealt with quite a specific use case. So about the application. It's pretty standard commerce platform, which has a few different single-page applications on top of them, on top of the various backend API services. So first of all, we have a checkout single-page application, which utilizes the backend to perform the checkout process. So it gathers payment data, customer data, and finally places the order. Later on, we have the storefront application, which handles the product catalog, the search, and the user account pages. And within this application, for example, the caching is quite important use case. And last but not least, we have a back office single page application, which essentially has access to the entire data set of the system and is mostly addressed for the customer service employees. How those applications are connected with the backend. So Roy mentioned that usually you will use some sort of data layer or some sort of backend for frontend. However, once we started that project, it wasn't so easy. So we had services that were connected directly to all the microservices in the backend side. So, for example, the checkout application was using the product service, the shipping order, some notifications, invoicing, users, and tax service. And you may say that it's kind of normal stuff when you are dealing with microservices. However, I don't agree in full with that. With such a use case, when you don't have a special gateway-like service, you need to expose all those services to the outside world, and the single-page application would consume those APIs directly. What would happen when you add the storefront application to the mix? Let's see. When you add the storefront application, it fetches mostly the product service, the shipping service to provide the shipping estimates, and the user service to provide maybe some promotions that are user-specific. How could we now change anything in any of those backend services? Let's say that shipping service would not require a different payload. We would need to change every single page application that is already connected. And we didn't even started to connect the back office admin application. As you may notice, it quickly will evolve to architecture like this. So more or less spaghetti-driven architecture, when every backend service would be called by every frontend application. And given this architecture, introducing any changes in any of the endpoints could potentially require changes in all of the frontend apps. So how our team tried to resolve that problem? First of all, as Roy suggested, we tried to use backend to frontend approach. At least we analyzed that idea. So if you are not familiar with that design pattern, backend for frontend means that every frontend application has its own dedicated backend service, which is sort of a data layer for that specific frontend. So in our use case, we would need to introduce an API gateway service for each single page application. That would allow us to shape the data directly for every front-end app. However, it will be quite hard to maintain or refactor because the number of backend services will grow quite rapidly. So we rejected that idea, and we have shifted to a different approach. So since we are on the GraphQL Meetup, we decided to go with the GraphQL-based API gateway. Unfortunately, we didn't have such a cool tooling as Roy mentioned with all those directives and automatic mapping. So we have developed an in-house solution. We introduced yet another microservice to our stack. In this case, it was a Python microservice, which was powered by Ariadne GraphQL library, which allowed us to cover all our microservices with one specific API, which was GraphQL API. Overall, now the system felt clean and organized. Every single page application was connected to the GraphQL data layer, and the GraphQL data layer was dealing with all those specific calls to backend services. So before we have this, and after the introduction of the GraphQL layer, it felt like this. So much better. However, let's proceed to the details. How the GraphQL API gateway is developed in our case. So as I mentioned, we used Ariadne GraphQL library to power our GraphQL server. To make it asynchronous, we used Starlet as an ASGI server, which those components play pretty nicely with each other, and the API is pretty robust. As we used the GraphQL library of Ariadne, we needed to be schema first. So before we deployed that service, we needed to describe our API with GraphQL schema definition language, which acted like a contract between our front-end apps and backend apps. So, moreover, what are the overall benefits of that shift? As I mentioned, the GraphQL schema acts like an API contract. So the front-end developers are taking active part in the API design process because they know which data they need and which operations they need to perform on those data. Also, thanks to the GraphQL schema, which is static, we, as a backend developers, can easily manage the deprecations of certain fields using the built-in deprecated directive. Also, as a bonus for the front-end developers, the integration with TypeScript is awesome in the GraphQL world. So once we have that schema established, the front-end developers could start their work as soon as the schema is deployed. They don't even need the fully working API. Additionally, all the backend services could remain hidden in the secure network. They don't even need to be exposed because the GraphQL facade is the only key point that is exposed. And that obviously increases security. Moreover, the backend APIs could be easily refactored because until we keep the contract stable, so we don't mess up with the schema, we can safely refactor the services, move the data around, merge them, or even create new ones. Because the front-end applications don't care when the data is stored. The products could live in the product service, in the Elasticsearch, or anywhere you want. It doesn't matter. Also, it's quite easy to connect the new single-page applications or reshape your data because you have that schema that describes your API, and once you want, for example, create a mobile application, you, as a developer, can see which data is available and what do you want to do with that. There is almost no effort on the backend side when you want to create a new application. New clients just use the data as they need to display it. Also, there is also automatically generated schema documentation, which can be introspected. So the developers could be pretty happy about that. However, there are also some issues and difficulties along with that list of benefits that I already mentioned. What are those issues? First of all, as everything in computer science, naming is hard. In our use case, we don't have federations as in Roy's scenario. So we have only one shared namespace. So we needed to think twice: what is an order or what is a product? Especially when we had, a client-facing application or the customer-facing application versus the admin layer, and both of those applications were connected to the same API gateway. So naming should be really considered. Also, the error handling is quite tricky because you have distributed systems, and you need to be mindful about the error handling. So as I asked the question to the previous talk, we need to prepare on the backend how to deal with the outages that could happen, because in the distributed system, outages are quite natural. So also the front-end applications should be prepared for random null values when that outage situation happen. And the last but not least issue with that approach that we have taken is that extra effort that is needed to expose the public API. Because in our case, we have to keep the REST interfaces of the microservices, because the services sometimes are communicating with each other using a standard HTTP. However, the GraphQL is used for the client-facing applications, and that GraphQL is exposed by the API gateway. So sometimes we need to create the same API twice. However, this is not that bad in the end, because once you establish proper tooling or a proper internal utils that connects REST endpoints to the GraphQL ones, it's pretty straightforward. And in our case, this is just a trade-off which we have chosen to follow. Yeah, so I believe that's all. I phrased the lightning talk time limit. So thank you all. Do you have any questions?
Thanks, Arthur, for sharing your experience. I can definitely confirm the advantages it comes with on the front end firsthand, because actually me and Arthur were working on the very same project that was showcased during the presentation today. So yeah, maybe let's jump into some questions. Do we have any? Okay, looks like no questions. So thanks again, Arthur.
Thank you.
Okay, so before we jump into the next presentation, if you just tuned in, a quick reminder that if you do have any questions, be sure to ask them during the talk. It will be easier for us to pick it up and ask the presenter. Okay, it's time for our next guest. Vignesh will tell us about GraphQL, blockchain, and Web 3.0. Hi, Vignesh.
So am I audible?
Yeah, you're live.
Okay, yeah. So hello guys, so this is Vignesh, and today I'm going to discuss about GraphQL, blockchain, and Web 3.0. So 3 different topics, 3 big domains to discuss. and I'm pretty sure it's going to be interesting, especially because of the relation between all three. So, yeah. So to get started, just let me start with an introduction about myself. So I am Vignesh, as he introduced. So I call myself a generalist. That's how I like to introduce myself. I work with the guild as a software developer, which makes open source GraphQL developer tools and provides consultancy to other companies. And I am a founder of a startup called Time Campus. I'm still working on it, and I'm the CTO of Convent.ai, which is again a Singapore-based startup which is working on conversation intelligence. So this is my profile. This is why I said I like to call myself a generalist. I am a product consultant at Shipper. So just to give you an intro on the org I work at. So this is what the guild ecosystem looks like. So if you are using GraphQL, by any chance, you would have come across one tool or the other from the guild ecosystem. So yeah, it's a pretty tightly coupled ecosystem. At the same time, it allows you to use any one of the tools from the services which they provide. So you might have used any one of these tools if you are working with GraphQL and Node.js and TypeScript, most probably. And this is what we are doing at Convent. So we are actually building, a recruiter bot for everyone, for candidates. So to attend assessments better, to attend intelligent assessments better. That's what I'm doing. Just to give a quick intro on what I'm doing behind the scenes. And yeah, before we jump onto the talk, like today's talk is going to be about blockchain and other parts of GraphQL. If you want to go deep into GraphQL, I have 2 other talks which you can actually go to YouTube and you can find them. Yeah, let's quickly get onto the topic now. So when we are talking about Web 3.0, the reason for the Web 3.0 to evolve, has been manifold. So we started with the PC era, then we came to Web 1.0, which was typically called a read-only web, and then we came to Web 2.0, which is where we are in right now. So where we have social media, interactive content, rich text, and things like that. We add more interactivity in Web 2.0. That's where we came in Web 2.0. And then now comes Web 3.0. Now the future of web, which is typically called Web 3.0, is where we are headed. In fact, it's already there. So just to give you an insight on, what the difference is between Web 1.0, 2.0, and 3.0. So as I told you, 1.0 was read-only, 2.0 was information interactive, and 3.0, it's more decentralized, private, and secure. We will come to see why we moved to Web 3.0. But before we do that, if you're using any one of these apps, Facebook, LinkedIn, Twitter, Instagram, Google, YouTube, anything for that matter, this means that you are using Web 2.0. The reason being, so there is an entity which is basically controlling your data. There is an entity which is actually helping you complete transactions. And this is a centralized entity we are talking about. So if you are talking with Facebook, if you're transacting with Facebook, if you're sending a friend request in Facebook, you're talking with Facebook. So if Facebook is down, then you pretty much cannot do anything in Facebook. So and Facebook holds control of your data. So that's how it is right now. So for instance, this is how a Web 2.0 architecture looks like. So if you are using any one of these apps which I just showed you, so this is what the architecture looks like. You have the browser which the user is accessing. You have a front-end layer, which is what is being rendered on the screen, which is typically in JavaScript, HTML, and CSS. Then we have a backend layer, so which can be in any one of the languages: Node.js, Python, Java, Golang, Rest, whatever you call it. And then we have a database layer. So we call it as a 3-tier architecture, right? So we have front-end, backend, and database. So that's what we have in a typical Web 2.0 application. And this has been working very well for quite a long time now. But, as, the web evolves more and more, the threads also evolve more and more. The needs also evolve more and more. So the best way to find, the best reason for new innovation is a problem, right? So that's where Web 3.0 also came into picture. So Web 2.0 had problems. and that's where Web 3.0 had to come in to solve those problems. So if we want to look at what the problems are of Web 2.0 before we even jump to Web 3.0. So one thing is, it was a single easy target for hackers to come in, take your data, do anything with your data, and basically we were trusting all our data with a single entity, and we assume that nothing will go wrong with the data, which we have been proved wrong for quite some time. We saw Equifax, we saw Facebook data breach, and we saw a lot of data breaches in the past, Visa data breach. So all of these are problems of entrusting your data in a single entity, and that's the problem with Web 2.0. And also, you assume that your data is not being sniffed, your data is private. That these are all the assumptions we make, but in reality, that's not the true picture, because you are ultimately putting all your data in a single place, which is something like a single point of failure. So if your data is lost, it's lost. So if so your data can be modified by the party whom you are entrusting to as well, without your knowledge. So things like this can happen, and there is no way to for you to enforce any rules, enforce any framework to control this. There is no openness, there is no transparency, and sometimes your data can be mishandled in any number of ways. So this is the challenge we saw in Web 2.0. But at the same time, it is not without its own advantages. It comes with advantages as well. Now let's come to Web 3.0. Before I go to Web 3.0, the reason I'm talking about Web 3.0 today is, so when we are talking about GraphQL and the future, so that's where GraphQL plays a major role in putting together Web 3.0. We will see why. So when you see Web 3.0, it involves a lot of components or modules within. So one is, the web has to be semantic, which means that it has to contain meaning. It should not be just about text. It should not be just about keywords and values, but it should be graph of data. So that's what we call, right? So we have data which is connected, and connected data conveys more meaning. So we have a connected data, we have intelligence in data, and we have ubiquity, which means that it should be accessible. Data should be accessible anywhere. Then we have enhanced connectivity. We have a peer-to-peer network. Now peer-to-peer network is what we will be concentrating on today predominantly. We have 3D graphics. So all of these are other portions of Web 3.0. So Web 3.0 doesn't just include a decentralized network. So if you saw the challenges before in the previous slide, the major challenges were because the data was entrusted to a single entity. So if we were to avoid issues or problems with our data caused because of entrusting our data to a single entity, then the best way to handle that is to actually take the data, split it into multiple pieces, or distribute the data as we call it, and make sure that there is a signature or trust certificate for your data, so that we know that it is not tampered with. So we also have a clear audit trail on where the data goes and things like that. At the same time, maintaining our privacy. So if we want to have all of these in place, that's where Web 3.0 actually comes into picture. So now when we talk about Web 3.0 and Web 2.0, so rather than just putting in the terms, so let's have a look at all the apps between 2.0 and 3.0. So when you're talking about 2.0 and 3.0, so browser we have Chrome in 2.0, 3.0 we have Brave. So Brave, there is something called as Basic Attention Token, or BAT as we call it. So people are paid for viewing content. Creators are paid for viewing content without having to track your activity. At the same time, we have storage, Dropbox and Google Drive 2.0, which is centralizing your data all in one place to a single entity. So if you're putting your data in Google Drive or Dropbox, you're basically entrusting your data to them. So, but you have IPFS, which is distributed, and it is pieced to multiple people. So, and you are signing them. So IPFS is interplanetary file system, which is distributed across the globe. So like this, you have parallel technologies between Web 2.0 and 3.0. So you have Facebook and Twitter, we have Steemit and Akasha. So this is how the ecosystem currently looks like. So this is the transition we are making to the future. It has its own challenges as well. We will talk about the challenges of Web 3.0 in the future. But when we are talking about the apps like these, so we call it dApps, or rather decentralized applications, because it is distributed and not centralized. So that's the reason we call it as dApps, while we call Web 2.0 as apps. So this is how a typical Web 3.0 application looks like. We have cut all the complex parts. It's just talking about the most important parts of Web 3.0. We will come to the complete architecture diagram in just some time. At the end, if I find time, I will show you a demo as well. So let's see. A person is again accessing the browser, again looking at the front end. So the same thing applies here. But in the back end, if you see, you have an Ethereum virtual machine, which is going to basically help you take the smart contracts which you have actually written in blockchain. Or rather, before we come to even Ethereum virtual machine, so what we have in the backend is a blockchain network. So blockchain network is where we are we call it blockchain network, where we are not we are not centralizing all the things in one place. We are rather decentralizing all the things we do into multiple pieces. We are basically making the data immutable. So we will quickly look at what blockchain is, and then probably we'll come to this again. So yeah, this is what blockchain looks like. So it is programmable. So a blockchain is a programmable technology, which means that you have smart contracts. So smart contract is something where you have logic. So let's say that I have $1,000 and I give $1,000 to someone, a person who is going to basically rent me his house. So I am going to pay $1,000 and he's going to rent me his house. If that's the case, that's the contract I have with the person. So so in this case, in case of blockchain, it's something similar. So we are basically having multiple states and a contract which is nothing but logic, which will help you change from state A to state B. So if you want to change state A to state B, you have to execute a logic. And similarly, you have blockchain networks are secured because you don't actually lose anything. Everything is encrypted, everything is hashed, and everything is signed as well. So even if something is tampered, you can always verify the signature. It's anonymous because you can't actually understand who put the block in the blockchain. It's completely private unless you actually make it public. It is possible to make it public, but by default it's private. And then it is distributed by nature. So you don't centralize all the things in one place, but rather all the data you put, all the logic you have, everything is distributed across multiple people, and it's immutable. So which means that the data you put in already cannot be modified directly. Rather, you are actually going to have to create new copy. It's something like a ledger, like an account ledger, where you create another copy of data with the updated value. So this is what we call a state change, right? And it is timestamped, so we can clearly monitor when the block came into the blockchain, when the and what happened at what time it happened. So all of this can be clearly understood in blockchain. So this is what blockchain network looks like. So I understand this is a GraphQL meetup. We will talk about GraphQL soon, but just to give you a background of how things work, I will just quickly have a look. So now that we talked about blockchain, Ethereum is a type of a blockchain platform. It's a sort of a framework where you have smart contracts in place, which is going to have logic to basically change the value from state A to state B, and that's smart contract, as we mentioned. And we have blocks of data. And blocks of signed data, and we have Ethereum virtual machine, and its job is to basically execute the smart contract, execute the smart. First of all, convert the smart contract to bytecode, execute it, and then once executed, the final data has to be returned to the blockchain. That's the job of Ethereum virtual machine. So Ethereum is one of the type of blockchain networks. There are others as well. So I hope you got a gist of it. So this is how the process looks like in blockchain. So a transaction is requested and authenticated. So first of all, you start with the transaction you initialize the transaction first, and then a block is created for the transaction. And if you create a transaction, the same data, the data is sent to every node in the respective blockchain network. So for instance, if you create a block in Ethereum mainnet, the same block information or metadata is published to all the blocks in the Ethereum mainnet blockchain. And we have the nodes which validate the transaction, which says whether this is the right transaction or not. You have proof of work. The block is added to the blockchain. So the reward is given because for people to participate in blockchain and for people to actually do work to verify the data we have in blockchain, we need some kind of incentive. That's why we have a reward as well. And then the update is distributed across the network. Since it's a distributed system, the entire network needs to know about the rest of the network. I mean, every node in the network needs to know about the rest of the network for it to understand where a specific data lies or what happened to the state, and to also come to a quorum on what the final value of the data is. And then finally, the transaction is complete. So I know I'm going a bit fast because we have to jump into the important parts. So now you may ask, what about cryptocurrencies? So I am not talking about cryptocurrencies in today's meetup, but yeah, we have a lot of cryptocurrencies based on blockchain. So cryptocurrency is like an implementation, blockchain is like a protocol. So we have Bitcoin, we have Ether. Ethereum is a network, and Ether is the currency. And we have Solana, we have Dogecoin and other cryptocurrencies which are built on top of the blockchain protocol. So we are not talking about cryptocurrencies here. So, and when you're talking about blockchain, there are multiple different types of blockchain networks or multiple implementations of blockchain. So we have Hyperledger, Coda, Quorum, and again, I'm not touching this here because this is not a blockchain meetup, but overall, I would recommend Hyperledger, especially because Hyperledger is hosted by the Linux Foundation, so it has more backing, more community following than other blockchain networks. It has more maintenance than other networks. While all of these three are private, it supports private, it supports public, it supports high performance. So it supports all of these. The feature set in all these three are almost the same, but the backing is different. So that's why I would ask you to go for Hyperledger if you are going for something else. So, and just to give you an insight on how a contract looks like, so this is Solidity is the language in Ethereum, which is where which is what is used to write smart contracts. So this is how a smart contract looks like. So in Solidity, so this ultimately cannot be processed by Ethereum. So Ethereum has to convert the smart contract to bytecode so that it can process that and insert it into the blockchain network. So ultimately, the smart contract is converted to bytecode. Smart contract is nothing but the logic to help you move from state A to state B. And this is how you write smart contracts. And when you're talking about blockchain transactions, so you have all of these: contract code, transactions, previous hash, data hash. So this is how the complete verification flow goes. Like initially a block is published, then all the verification happens, everyone in the quorum agrees that this is the right transaction, and things like that happen in a blockchain network. So this is pretty complex to actually look at from the outside. So that's why we came to a decision, okay, enough is enough. So that's when we thought, okay, we need to have a better way to do all of this. We need to have a better way to make this easier for the client-side applications to consume. So, we cannot have this kind of complexity in the backend and have the client-side or the browser consume this kind of blockchain. Right? The problem is we are not just adding complexity to the backend, but also adding complexity to the front end, because we need to consume all these events in the blockchain for us to render in the front end. That's where the graph came in. What the graph said is, okay, we will handle all of the things with respect to the front end of the blockchain, which means, so graph is nothing but just imagine graph like a graph like Google. So Google basically indexes websites and basically presents the search results for you behind the scenes. So ultimately, it crawls all the websites, it indexes all the websites, and ultimately, basically provide you the search results whenever you search for it. Similarly, you have the graph, which is indexing the data in blockchain network. It is indexing all the blockchain networks, and ultimately presenting you different subgraphs. So what you can do is you can query the graph for data like you query Google for search terms. So it's like a single point of contact for querying all the data from your blockchain. So you don't have to go and monitor the events. You don't have to update the contract regularly, but rather you can index the blockchain network you have using the graph. And once you index it, you can actually start querying all that you want using the API which Graph provides. And the front end for the graph is GraphQL. So then now this is where GraphQL comes into picture. So now to give a pause and discuss about all the things we discussed till now. So ultimately, we have a Web 3.0 app which has a distributed backend, which is based on blockchain. Ethereum is a type of blockchain network. So we have an Ethereum-based blockchain network behind the scenes, which is ADAP. So these Ethereum, blockchain networks are regularly emitting events on what happened in the network. Like as soon as any change happens, it emits events. So that's what you see here as events. So all of these events are captured by the graph or indexed by the graph, and you can query those events indirectly. So ultimately, this is how the final architecture looks like. So you have, this is quite complex, I know, but if you are venturing into the world of Web 3.0 at present, in fact, this is the biggest limitation of Web 3.0, to be honest. So I might not be a very big advocate of Web 3.0. At the same time, I'm not opposing Web 3.0 as well. The problem with Web 3.0 is it is complex for beginners to start with. So that's the biggest problem with Web 3.0, as people are trying to make it easy, but still you have to put together all these tools to have proper end-to-end Web 3.0 application. So you see a tool called MetaMask, which is used for authenticating, or it's like a gateway into it's like a great gateway into blockchain. So you have basically something which authenticates or signs the data which you have, signs you as a user. So MetaMask is gateway service to blockchain. So you have IPFS, which is the interplanetary file system, which is distributed file system across the globe. We have Infura, Alchemy, MetaMask. All of these are basically blockchain providers. The reason we need providers is because either we have to host the blockchain network ourselves, or we have to use third-party providers. If we are hosting, let's say, an Ethereum node ourselves, it will be not feasible, because every time you have an Ethereum node in place, you are not just having your data, but you're also having the data from all the blocks in the entire global Ethereum network. So it will take days for you to pull all the data. It will take huge compute power, bandwidth, and everything to host it all in your laptops. There are third-party services available to do that for you, because every block, as I told you, holds a copy of the entire Ethereum network. And we have Ethereum virtual machine smart contracts, blocks, as we mentioned, so which forms the backend of the blockchain. And we have Polygon. We will talk about Polygon in a bit, but we have Graph here. Now the Graph's job is to basically make it easy for the front end to query the backend. So ultimately, GraphQL is where this is where the GraphQL part comes into play. Where GraphQL is going to be used as a query language to query all the data from this Ethereum virtual machine without exposing the complexity of blockchain. to the front end. So that's how it works. And Polygon is used because Ethereum virtual machine, in Ethereum network, when if you are doing any transaction, it is actually paid, and it takes long time to fulfill or reach finality. So what people do is typically have a parallel blockchain network which does computation parallelly, and then finally aggregates the computer data and inserts the computer data onto the main blockchain. So it's like a parallel existence to blockchain where you do all the stuff temporarily. Just assume it like a rough notebook where you take down all the rough notes, and then finally when you know what you have is right, then you shift to the Ethereum network. That's so that is more faster than doing it directly in Ethereum network, and it has other advantages as well. So this is how complex the blockchain app looks like. And as you might know, I don't need to explain this because you are in a GraphQL meetup, but this is the one which you see in the left is REST, and the one which you see in the right is the GraphQL API. So you have one endpoint to query and multiple sources of data which you can query. So again, this is how GraphQL looks like. Now talking about the subgraphs, this is what the Graph Explorer provides. So this is how the different blockchain networks are hosted in the graph. For instance, these are all different contracts or different networks, all of which have their own GraphQL endpoint. So you can basically query the events on the graph and you will get the data out of it. We will quickly see that now. How much time do I have? Okay. So let me quickly take you through a quick demo so that I'm just skipping this. And by the way, just to give you an insight, GRT is the graph token, which is like which is like a currency or metric used to identify the value in the blockchain network. So GRT is made by the graph. So I don't want to go through this now because we are short on time. And yeah, I'll quickly show you the demo just to give you an insight. Probably if we find time after that, we can discuss more. So this is a network which I created already. And let me quickly open up the project which I created. So ultimately, this is how a subgraph definition looks like. So you basically mention all the configuration for the subgraph, and you basically mention the mapping parameters. So let me quickly take a new project and I'll just do it for you. So probably it will take me 5 minutes. So let's quickly do the demo and so that you will get an idea on how it works. So the first step to starting a blockchain is you need to first step to publishing to the subgraph in the Graph Studio is basically to make sure that you have the tools installed. So first step is to install Graph CLI. So I'm getting the Graph CLI installed. So I already have it, I guess. So I have the Graph CLI installed. And the next step is to actually initialize my subgraph. So for this, what I do is, so I go to the graph.com. So if I go to the graph.com, what I can actually do is I have to log in. So I can log in through MetaMask. So there is something called as Explore Subgraphs. So I just click on that. So let me, right now I am already logged in. So if you are not logged in, you have to use MetaMask to log in. So probably you can Google it and you will find a way to log in. So I have to click on Create Subgraph. So these are all the different subgraphs which are already available in the graph. So now I am putting my subgraph in the Ethereum network. So that's why I select Ethereum mainnet. I set the name of my subgraph to be Zora test. I say continue. So a new subgraph is created for me and I get a deploy key. So basically what I am going to do is, this is an NFT marketplace where there are multiple media galleries or multiple media being hosted. And if you see, each and every media has its own contract address, token ID, the blockchain network, and other metadata. What I'm going to try to do is basically query data from Zora using using the subgraph studio in the graph, using GraphQL. Basically, ultimately this is a blockchain network already, so I am going to query all this blockchain data using GraphQL. That's what I am trying to do. So let me quickly do that. So I go to okay, first step which I need to do is, so I have commands in place. I'm just copy pasting it just so that I save time. So the first thing is I need to change the name of my network. So here in this case, the name which I created is Zora test. So I need to replace Zora test and subgraph studio from contract. So I will just explain what this command does. So we are initializing a new project. We are setting the name of the contract as token, and we are specifying the name of the subgraph which we have in subgraph studio. We are indexing all the events so that whenever so ultimately we are trying to generate code from the contract. So if we do this, what it's going to do is it's going to ask you, what protocol do you want to use? Do you want to use Ethereum or do you want to use Near? So I say Ethereum, and it already has the name of the subgraph because we already specified it. I say Zora test. So Zora test. I want to create the blockchain in mainnet. So I select mainnet. So there are multiple types of networks in Ethereum. So there is mainnet and there is others as well. So you can have a look at it later. So contract address, so true. Okay. So I need to specify a contract address. So right now, if you see Zora.co, this is what I told I am trying to query, right, through GraphQL. So here I have my contract address. So I just go take that, I paste it here. Okay, it got my ABI, application binary interface. So probably for some other day. So now it's going to create the project for me, initialize all the dependencies, scaffold everything. So ultimately, I need not do anything apart from just waiting for some time. Am I over time? When I started. Okay. So what I'm quickly going to do is, so I already have a project generated now. So what I need to do is, if you see this schema generated, you have all this schema. This is a GraphQL schema which you see here, which is going to be used for querying the respective blockchain network. I am going to replace this schema with my own schema, whatever I need. So I have a token type, I have a user type. So what I'm trying to do is I'm creating two types. These are custom types created by me. I'm specifying, okay, these are the fields I want. These are the data types, like you specify GraphQL schema. So I mentioned these are the two types I need. And then I go to subgraph.yaml, which is going to be the configuration for my entire subgraph. So if I have to specify any changes to my subgraph, this is where I specify that. So I basically go ahead and specify the start block ID. So this is something which you can get from Etherscan. So I don't have time to explain this right now, but if you go to Etherscan, you will be able to find the start block ID for this respective contract. So there is a website called etherscan.io. You can basically explore all the blockchain networks here. So yeah, that's where I get this start block ID from. So now ultimately I don't need all of these functions. These are functions which will get executed when the respective event actually happens. So I am getting rid of things which I don't want. I just need just two events. So I'm just taking that that alone into picture. I'm getting rid of all the things I don't want. Now the next thing is, again, I have the code already in place. So I'm just replacing the code for the sake of time. So we have all of these. So now that I have the schema in place, I need to basically generate the code. So first thing which I need to do is I need to generate the types for the respective schema from the code. So I run graph code gen, and sorry. Okay, I'm in the wrong directory. So I go to Zora test. I run graph code gen. Now what this is going to do is it is going to look at my GraphQL types. It is going to look at my configuration, and it's going to generate all the things for me in generated folder. You see token.ts and schema.ts, which is generated, which will basically query the network, query the blockchain network, and give me the data. So ultimately, it's generating me all the helper functions I need to basically query the network when I do the code gen. So now what I do is ultimately, so the final piece is this, where we actually specify what we want to do. So if there is no token, we create a token, and we assign a contract, and we basically save the respective token. If there is token, we return it. Similarly, if there is no user, we create a user, and then save it. So ultimately, there is token and user. So you will get a clear idea when we actually do it. So now the next step to do is, so I need to authenticate first with the studio. So I guess I am over time. So what I will do is I will go to the existing network which I have, and I will quickly show you how the query works, so that I don't take the next speaker's time. So this is a network which I have already created. Ultimately, when you deploy this network in the blockchain, this is how it looks like. So you have the query, you have the different data types. So ultimately, if I just query the first 5 tokens, so I get all the content in the respective blockchain network. So ultimately, what I did so far is I created, I have an existing blockchain network which is Zora. First step. Now I am what I did was I used the same contract ID. I created my own subgraph. I deployed the subgraph onto the subgraph studio in the graph, and ultimately I am using GraphQL queries to basically query on the data on top of the subgraph. So I know for beginners this will be confusing, probably in a 30-minute meetup. So this might be too much for you to take in, but this might probably give you an initial start on how all of this works. So ultimately we are able to query the blockchain network for data, and this is how the data looks like. So if you want to go and look at the data, you can just go to the data and you will be able to see the data here, ours truly. So thank you. Yeah, you can actually see this demo here. I have pushed all the code, all the source code here, so you can have a look at the demo. So that's all I have for today. Yeah, probably any questions you have, we can probably catch up offline since I went over time. Thank you.
Okay, thanks, Vignesh. So let's see if we have any questions. Okay, so we have one. I've seen some confusion between Web 3.0 from 2001, Semantic Web, and Web 3 from 2021, which is the token-based decentralized web.
So yeah, semantic web is one part of Web 3.0 definitely, but that's just one piece which makes up the entire puzzle. Semantic web is definitely that, but the Web 3.0 is also supposed to be decentralized. So it's just one of the characteristics, I would say. So
okay, thanks. Do we have anyone else? Okay, looks like that's it. So thank you very much, Vignesh.
thank you.
And it will be time for our final speaker today, which will be Gerard Sans, and he's here with us live at our Mirumee headquarters. So hi, Gerard.
Hello. Well, this is an awkward situation because I travel here to Wrocław to give this talk, but unfortunately, it won't be possible to run this event in an in-person format. But anyway, I'm gonna do the streaming of my talk, and I'm quite excited because it's been quite a long time since my last talk, and I spent some time creating this talk for you. So I hope you enjoy it. And yeah, the topic of this talk is revealing what's the GraphQL secret superpower. So I hope you are excited. It's kind of a secret, maybe not so much of a secret, but I'm going to share it with you, and I hope you will be happy to attend this talk. Before I go into the topic, I usually like to present myself, and I'm Gerard Sans, and I'm a developer evangelist. I focus on web and cloud, and these are some of the places that I've spoken just before the pandemic. So you will see that I've done Europe, US, South America, and also Asia. The only place that I haven't been yet is in Africa. So that's going to be my goal for this year. I'm also working on this workshop. This is a serverless training. If you want to learn serverless or you want to learn about any of these technologies, feel free to join. It's a recorded training, and we go and build a clone of a Twitter app from scratch for you. And you can see that happening using all these technologies here. So let's go into GraphQL, and I'm gonna explain a little bit of GraphQL so we are all lined up. And these are the co-founders. So we have Lee Byron, Nick Rock, and Dan Schaffer. They built the initial spec for GraphQL. That was in 2015. And since then, there have been few changes. And I'm going to cover the latest specs for my talk. So here is a common explanation of the difference between REST and GraphQL. So you can see that REST have different endpoints. GraphQL move away from that, and we only have one. That brings many benefits, and we are going to cover one of them in this talk. And in order to do that, I'm going to be going into the server side. And I think a way to understand that is going through the query lifecycle. And this is what happens when you are in your web app, do an interaction, and that interaction will trigger a query. It could also be a mutation or a subscription, and then that will be sent to the GraphQL server, and it will go through different stages. So let's cover that. On the client, we can work with different front-end libraries. These are some examples. And at this stage, we are going to use GQL, which is a GraphQL query language. In that language, we're going to write our queries, and that's going to be going through a GraphQL client. There are many GraphQL clients. I guess most of you have used Apollo. There's also AWS Amplify that you can use, and that will trigger a query, a mutation, or a subscription, and will go to the endpoint that will be the GraphQL server. Here, the first thing that will happen is it will go through a parse stage, and that will break down the query, and it will first validate that it's correct. And in order to do that, we are going to use the schema. And the schema is going to use the schema definition language. And we are going to be working on that today. After that, it's going to go into the execution stage. So we break down the query. We validate that the query is valid. And then we will execute that query, what will end up being calls to different resolvers. That will bring the results from the backend. We can use any numbers of data sources in this phase, and that will send back the response. That will get to the GraphQL client and back to the client. And this will be the query lifecycle. Of course, after that first interaction, we can trigger another one, and it will follow exactly the same path. One thing that I want you to remember is that we have this GQL and SDL, and these are working in completely different environments. One is working on the client, the other one is executing on the server side. And it's mainly used on the validation, but it also participates on the execution and also dealing with the resolvers. So this is like a small intro. If we look at an example of GQL, it will look something like this. And this is a post query, and it will use the GraphQL endpoint. And we can see the response to that. It will come as a JSON, and we can see some similarities. We get the query, we get the same entry on the result, and then we get a string, which will be part of that query. So this is just a small intro. If we look at the schema definition language, we will have this structure where we define the schema and all of the operations that we can run through it. We usually have queries, mutations, and if we have real-time support, we will also introduce subscriptions. And they will look like this. Oh, by the way, we have a guest. It's going to be the Grumpy Cat, and it's going to give us some feedback. And in this case, it's saying that this is optional. So when you are defining your schema on the server, you can omit this step and it will still work. Okay, thank you. So let's look at a definition of a query. And this is an example of a to-do app. And what we can see here is an entry and that will return all of the to-dos. We can see the argument. We have a first that will give us as many results from the query, and then it gives us the type that it's a to-do type, and also tell us that it will come in the format of a list. If we look at the definition for the type to-do, we can see that it's 3 fields, and those fields are the ID, the text, and the complete, and that will be using the following types. So we have an ID, a string, and a Boolean. One thing that you can notice is the way that the schema is defined. We have fields at all of these levels, so it's actually recursive. And another thing that we can see is that all of them always follow by a type. And this is one of the benefits of the schema definition language, is that we can also define the validations. And that's the stage that I show you in the previous slide. We have also arguments, as I was telling before. We have the list. We also can specify mandatory fields, which we will use the exclamation point. And one of the other things that is exciting about GraphQL is the community. And today I was sharing this slide on Twitter. We can see that there's more than 83,000 members. This is information from meetup.com. So this is a really healthy and established community. So if you are interested, I would recommend you to join a meetup in your area and just keep learning about it. So why developers use GraphQL? I mean, there are many reasons. One of them is that the tooling is just fantastic. We can also see that abstracts the data access, the storage. So that's a clear benefit. There's also the type safety that we were seeing with the use of types. So we have a validated and structured way to communicate, the way to fetch the information from our API. And also it's collaborative. And this is the way that the schema favors communication between teams. So when you create your schema in and start building a new API, you can share that schema, and developers in the front end can start working at the same time that the developers on the back end start building the system. The other thing that maybe you are not familiar is that it's super fast. And this is because it was designed to be used for mobile apps, and you can use that feature also for web. So this is a little intro on GraphQL. And usually when I finish a section, I show a nice cat picture. So you can familiarize yourself with this. So this is the end of the first section. We can move on. So what's the GraphQL secret superpower? And we have seen a little bit of an intro, and maybe you have few guesses. Maybe you think that it's tooling. Maybe you think that it's introspection. So we have the schema. We can use that to know about the types and the different structure of our schema. But actually, it's none of those. And what I'm going to show now is the secret actually is extensibility. And when you think about it, it's how you're going to maintain that GraphQL API over time. And sometimes you want to add features, but you want to add features in a solid way. You don't want to introduce errors. You want to still be using the same resolvers, but maybe add some extra features. And you want to do that to different GraphQL APIs. And actually, GraphQL introduces what I'm going to talk today, which are the GraphQL directives. So this way is a way to change the behavior, but without actually changing the code, which is like really cool. And this is where the money comes. I picked this picture with the cat and the money. And I would say that this is not totally a secret, but not many people know about it. So I'm actually going to call it a secret superpower. So yeah, GraphQL directives. This is the superpower that I'm going to be talking about. And one thing that we can do with GraphQL directive is use these directives to annotate. So we can add metadata and also add custom logic. So we can change the behavior of our APIs. We can do it in two separate places. So as I was talking, we have the GQL, and these are the queries, and we also have the schema definition language. So we can change our API in these two places. Most of the examples that I'm going to show are on the schema side, but you can also build directives on the queries. So these are two different options that you have. So what can you do? Well, there's so many things you can do. People is doing analytics. People is doing performance tracking. You can add logging easily. Maybe you want to add caching. There's many things you can do with caching. Default values. This is a feature that GraphQL doesn't support natively. You can add default values using directives. You can also format data. Maybe you want to add some options to the datetime. You want to create your own type dealing with those, so you can do it. A lot of people is implementing authorization, and you will find many examples of that. You can add extra validation. We have also seen in previous talks that you can also use it as a gateway. You can connect to other GraphQL APIs and automate that. I mean, the possibilities are endless. So let's look how we can create our own. So the first thing that we are going to do is add the directive to the schema. So we will add a definition of it, and we will see an example. So this is an example of an existing directive, which is specified by. And what we can do is we can tell the GraphQL schema from where we are getting type from. And the way we will do that is providing a URL. In this case, we can see the identifier. This is the name. You can see that we are using a camel case here. One thing that I recommend you to do is use a prefix so it won't collide with other directives that may exist. Then you can also use arguments. In this case, we have one argument. You can also use directives without arguments. It just depends on what you want to implement. And then finally, we can specify a location where we want to use that directive or where we want to add this metadata. It seems like the Grumpy Cat is silent. Oh, no. We can also do another thing. I don't want to forget about it. We can also use repeatable. So if we add repeatable at the end of the definition, that means that we can use the same directive more than one time. All right. So we already created the definition. Now we can use it. So we have this type, which is using a universal UID. And we specified that we can use it on a scalar. So we could use it here. And the way it will look like is we can add, we use this add specified by, and we use the argument providing the URL. In this case, I've used a shortener, a URL shortener, but this is pointing to the specification of that universal UID. So you can add this information. It will be available for tooling. It will be available for your developers when they are creating the user interface. So this is one example. I picked one of the directives already available, so it's easy enough to follow. So how many locations can we use? Well, if we are talking about GQL, we have 8 possible locations. And if you want, you can take a screenshot. These are all of the different locations that you can use. So you can use it on argument. You can use it on the query level. We can see that we can use it on fields. And remember that these are on the query side. So this will be on the client. Then we have fragments, inline fragments. If you are not familiar with fragments, you can define fragments that will take few fields that you are going to use in different places in your queries. So you can refactor those into a fragment definition, and you just need to specify the type. There's also directives that can be used with mutations and subscriptions. So you can actually provide these extensions to your users. And we won't be looking at many examples on the query side, but we will be focusing more on the server. On the server side, we have 11 potential extension locations, and these are all of them. We are going to be covering some of those so you can add the directives in your schema. As you can see, it covers everything. There's also a cover for union, scalars, enums, input fields. You basically can change anything. And probably the most exciting one is at the level of the schema. So you can drop this directive in your schema and actually change the behavior of everything from there. So let's look into the details. I mean, that's another cat. I mean, I guess that's the first reaction. These are some of the people using GraphQL that were not available of that many choices. And yeah, that's quite scary, actually. Okay, so let's look into the native directives. And I'm going to go very quickly here. So actually, these are supported since the original spec. And these are skip and include on the query side, and on the schema side, we have deprecated and specified by that we already covered. So let's look very quickly at how skip is defined. So we have a normal definition. We have directive, skip. We have one argument. So it's going to take a Boolean. We can see that it's using the exclamation point, so it's mandatory. And then we can use the skip directive in 3 different places. So we can use it on a field, on an inline fragment, and on a fragment spread. Let's go over some of these with examples so you can familiarize yourself. So this is a query using the skip, and it's going to take a Boolean that is an argument, and we can see that. The way this will work is that we can decide in our query if we want to use the name field or not. So actually, we can introduce these dynamic queries in our clients. If we look at an example of an inline fragment, we can see that it works pretty much the same. The only thing that will change is how we use the inline fragment syntax. In this example, we can see how it works here. So we specify the type. So this will be a user type, and we can tell the query that if it's an anonymous user, we can include or skip the name. Of course, if it's anonymous, we don't have that field. So this will be usage of this directive. How we will look for a fragment spread, this is a slightly different. So we actually have a definition, a separate definition for the user name. And in this case, we have that spread notation, and we have the definition here at the bottom. It's very much like formal definition. The previous one, the inline fragment, it works more like an anonymous definition, so you can use any of the two. They work exactly the same. So if we have an argument that it's true, it will skip that field. We also have the deprecated. In this case, this directive, it's gonna provide us information about some of the fields that are not being released in the next version. So you have a deprecated notice, and you can use those in two different places. We can use this on the field definition and also in enums. One thing that I didn't mention is that we have a reason argument, and this is using a default message, which is no longer supported. So you can actually deprecate fields in your schema, and then this will inform the clients. So this is pretty cool. If we see at some examples, it will be used like this. So in your schema definition, the moment that you are seeing that this universal UID won't be supported in the future, you can introduce this directive, and then the clients will start seeing this while they are building their clients. So this will give them this extra information. If we don't use a reason, like in this example, it would just use the no longer supported, so we don't need to provide that argument. And another thing that you may not know is that you can use Markdown as well. For enums, it will look exactly the same, and in this example, I use obsolete. All right, so this was like the easy part, just showing the native directives. Let's go look into some more complex ones. The next one that we are going to look is Deferred, and this is in the workings. So it's still not defined on the GraphQL specs, but it's about to be released. And one thing that we can use Deferred is to improve the user experience. So let's look into an example of that. So let's imagine we have a query that is taking too long, and it will look something like this. So over time, we will have the request, and then we will have a part of the query that it's fast, but we will have another part of the query which will be a fragment of that query that will be slow. So we can see that it takes a little bit more time. What we can do from this point is give the response back to the client, and that will give us the initial load time. For this example, it took 850 milliseconds, so it's a little bit too much. And one thing that we could do is use Deferred for that slow fragment, and it will behave slightly different. So first we need to identify the part of the query that is slow and use the Deferred directive on that part. So the fast part will be exactly the same. One thing that we'll be able to do is provide a response on that initial fast part of the query, and that will give us a much faster initial load. So we can have user experience that it's 350 milliseconds faster. What happens after that is we get the result from the slow fragment, and then what we will use is a patch that will update the results for the client. So when we do the query using Deferred, we will use a different protocol. We will use HTTP patches. So we will keep listening to that request and we will receive the updates. So let's look into that. This is, as I was saying, an experimental feature, but it's going to come in the next release of GraphQL. So it's quite exciting. This is a directive that it's to improve the user experience, so the user doesn't have to wait that much. So the idea here is to postpone anything that is not essential and get the user some data. So you need to decide what data will be available and what data can come a little bit later. And you will use Deferred to express that. That will implement they will use a different protocol. This will be HTTP multipart, and it will just send the different patches as they are becoming available. So that will give us a very fast initial response, but that will be waiting for other patches to come later. So this is being implemented right now. There's different places where you can test it out, and I'm going to provide some links later. One thing that we are trying to do here is minimize the impact of the slow bits of the query. So if you find yourself in a situation like this, you will use Deferred to solve that. So it's quite nice. One thing that you need to realize is that fragments can only be of one or more fields. So you need to put these into a fragment. And I will show you an example of that. So how we use the definition for Deferred is we will specify, as we did before, two arguments. One will be if we want to use the Deferred, and the other one will be a label to identify the different patches. So this will be the label will be unique. So if you have different fragments, you can identify from which part of the user interface they are coming from. This will only work for fragment spreads. So this is something to take into account. And we will look into an example. So let's imagine we have this query, and I'm going to use this technique that introduces the Deferred directive. So we have this query. It's using the ID to get a user data. If we look at the user type definition, it's an ID, a name, and then a performance. And that performance is indeed another type, which is the employee file that will give us the final review. What happens here is that this is another system. So we need to access that external system that it's slow, unfortunately. So we have some data in our GraphQL API that is fast, and we have another data coming from another system that is slow. So we are going to try to fix it. One thing that we'll realize in these cases is that we get a slow query, so we need to dig a little bit deeper into looking what is failing. So we look at execution here. That will be a query. In this case, I'm using load user, and we get an ID as an argument there. This is the query. So we are using that ID, and I want the name and also the review that comes from the performance. So here, what will happen is this will be taking more time, and we can see that it's taking way too long. So one thing that, yeah, that's taking way too much. So what I'm going to do is I'm going to create a fragment. So we can introduce a fragment here. This will be a fragment definition. So we can use, for example, employee review, and it will be on the type user, as we saw on the schema definition. And I'm just going to add the part of the query that is going to be taken care of by Deferred. So the next thing that I'm going to do is introduce the directive. So we found the fields that are being slow. And the only thing that I need to use here is I need to use a label. And that will be the way how I identify the different patches. All right, let's ignore that. So let's see how initial response will look like. So this is very much like a normal response. We get the get user by ID, which is the query, and then we get the first field. I'm using Elon Musk here, and the only difference from a normal response is that it has this extra has next to true. And you can see what's going on below. We're getting the first response, and after this first response, we will get the patch. So this will be the initial response that our client will get, which is slightly different from a regular response for a GraphQL query. And then we will get a patch. The first field will be the label. That will be the identifier. Then we get a path that will be where we will add the information from this patch. In our case, that will be the get user by ID query. And then we get the information from that patch. In this case, we get the review. That will be sometime later. And we also get the information of has next to false. So now we know that this will be the last patch. So let's look at the client on the client code, and I'm going to use a React client so you can get all of these concepts in one example. So if we run this query, that will initialize the request, and at this time we will get the initial fast results. As the code executes, we will get these fields, and this is a regular implementation. The only field that is new here is the loading state. So we are going to get a loading result. And we can use that to render a loader, a spinning, and this will be the output. If we get any errors from that initial query, we will be able to show them here. And we can also render the initial data. Now we are waiting for that result to come. And we can see at the bottom that we get the response from the fast query, and we can show it. So I can use an employee component and use the information coming from that initial response. Another thing that I can do now is I can render the employee review, and that will be a separate component. And I can use the information to show the spinner. And the information that I'm using here now is the loading state. So I can use that to show the spinner. As you can see, we are receiving the information at different times. And when I get the patch, then I can use the information from that second response. So this is the whole example. This is coming in the next spec for GraphQL. There have been few changes to the original spec, so this is an exciting change that is coming. All right, so there's a lot of things that GraphQL can add with directives. And after looking at some examples and also looking at Deferred, I wanted to give you a little bit more detail. So I'm going to look into some examples of custom directives. This is a little bit more advanced, but I think it's worth it. And the first example is I'm going to be using this API, which is Chuck Norris. And this is a very simple API, a REST API, where you can call it, and it will give you like a funny remark, a funny joke from Chuck Norris. And I think it's easy enough to follow. So this is what a response, a JSON response will look like when you call the API Chuck Norris IO. And we can see few data here. The one that I'm interested is just the joke. So here is the Grand Canyon was caused by Chuck Norris pissing there once. So this is very impressive. So this is the example. What I want to do is I want to create a directive that is gonna make the call to this API, and it's gonna take that field from the response. So this is very similar to one of the examples that we saw in a previous talk. So let's implement it. First, we are going to define the directive as we saw before. So we use directive. I'm going to call it rest, and it's going to use two arguments. The first one is going to be the URL, so it's mandatory. And the second argument is going to provide the property. As we saw on the JSON, I'm going to use the value, the property value, because it contains the joke. I'm going to use it on a field, and this is how it's going to look. So I'm going to use the hello query, which returns a string with a welcome message. And I'm going to change it now to use this rest directive. So actually what I'm doing here is I'm changing a query, and it's going to be using a different API. In this case, it's going to be the Chuck Norris API. So it's very flexible. So this is a very innovative approach. Of course, you need to be careful what you implement, as you need to also take into consideration error handling and some other configuration options. But this is an interesting field that I recommend you to explore. And this is just a little example. I wouldn't release it exactly like this, but it's to show you what you can do with it. So here we can see the example. I'm just using the endpoint. So this is the endpoint to access to the jokes, and then the property from the JSON response. So that's going to be happening on the directive. So let's look at the implementation. I'm using here a sample implementation. This is coming from the Apollo server. So this is the code that you will use. And we can see here the example of the query that I was showing you before, and I will go through the code so you can see how easy it is to implement. So one thing that you will find is the location. So this is the object field. We are using that on an object. We can see that on the hello string. This is where I'm going to use my directive. And that will return a function that takes a field config. And that's important because that's what we're going to use to implement our directive. So I'm taking that, and we are going to take the metadata from the directive, and I can do that by providing the schema. That's one part of the arguments that you can see at the top. Then I'm going to take the field configuration, and I can use the name of my directive. That will give us the information of the directive. In this case, you can see it at the bottom. That's the URL and the property. And then if that comes back with a result, I'm going to take the URL and the property. And what I'm going to do is I'm going to use fetch to make the call, and then take from the response, I'm going to use the property and return it back. So let's look at that. We can see here that I'm creating this async function that will be waiting for the fetch to return. And I'm going to take the JSON response from that, and then I'm going to pick the field that it's the joke in this case. So as you can see, that's the whole code. So I would say that it's not crazy. It will take some time to implement, but it's something that you may want to explore. I've created this example so you can play with it live. So this is bit.ly Wrocław -rest. So you can experiment with it on your own. I also created another example, which you can check later. And it's very similar. What we'll do is take the result of your resolver and make it uppercase. This is another example. and you can see the code here. In this case, I'm gonna replace the resolver for that function, and I'm gonna use the original resolver to change the result to uppercase. So this is another snippet that you can use. I'm also providing you with the code so you can play it live. I just checked it before the talk, so it's still valid, and you will be able to change it if you want to try different directives. So everything is possible. I hope I show you the things that you can do with directives. Probably you were not aware of them. People is using them in different ways, so I hope you can create some nice directives from now on. So yeah, take it to work, make an example tomorrow. Yeah, tell me how are you going to use it? If you want to know more, you can use GraphQL tools. They have implemented a few of these directives and more, so you can see actually the implementation for some of them. There's also another resource that I want to share, and this is GraphQL Elix, where you can play with Deferred. You can also play with Stream, which is another directive that is coming. And this is a nice server where you can play and use this with your current GraphQL server. There's also this resource, which is GraphQL Awesome, that makes a collection of GraphQL resources. So this is also another resource I want to share with you. Thanks for listening. That's all. So Jacob, okay, yeah, sorry. All right, so we are moving now to the Q&A, and I'm just gonna go over the questions. So let's see the first one. So is Deferred on the HTTP layer working like long pooling, or will that make two requests? Okay, so this is using the HTTP multipart. So it's part of the HTTP spec. The only thing is that you need to be using that, and it has like wide support. So actually you don't need to change anything as long as you are using HTTP multipart. And it will keep one request open. It's not long pooling as it is, it's HTTP multipart. Okay, so another question, how does error handling work if there is an error retrieving the deferred patch update, and can this error be returned to React? Well, it works exactly the same. So what will happen is if you are making another query, that will come back with the different arguments, and this is the loading and also the error. And then you have access to the response using the data. So it's working exactly the same. The only thing that it's not defined is how it will be implemented on the GraphQL client. So I'm showing here what Apollo has shared. There are a few articles showing examples, and I'm using these examples from Apollo. The final implementation, it will depend. Once the GraphQL spec is released, we will see how the final implementation will look like. But it will look more from the example that I've shown, that's coming from GraphQL Apollo. Any more questions? Okay, so that was the last question. Thanks a lot for listening to me. I'm gonna call Jacob to finish the event, to close the event. Thank you.
Yeah, thanks, Gerard. Great as always. So this was our final presentation. So with that, I would like to once again thank to all our speakers today for doing those great presentations, and stay tuned for the next event, and hopefully see you then. Bye, guys.